Good afternoon, everyone, and welcome to the Trenching Safety Overview webinar. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel, and if you could, go ahead and type in your initials and send those to us as an informal roll call for today's session. And I see those responses arriving already, so thank you for that. Throughout the webinar presentation, please use the questions box to send in any questions you might have, and I'll be dispatching those periodically to the instructor for comment. Please note also that the handout section of your GoToWebinar panel includes 2 PDF resources that are available for reference. With that, we'll go ahead and turn things over to Raymond Brushart with our Ohio LTAP Center, who will provide additional comments and also introduce our main speaker for today's session. Ray?
All right, thank you, Mike. Good afternoon, everybody. As Mike was saying, my name is Ray Brushart, and I'm a safety circuit rider here at the Ohio LTAP Center. And I have the pleasure today to introduce to you Ms. Mona Weiss from the Ohio Bureau of Workers' Compensation. And she is a safety consultant specializing in construction. And she achieved her Bachelor of Science in Occupational Safety and Health from Murray State University back in 1988. And prior to joining the Bureau of Workers' Compensation in 1993, Mona worked for 2 Forbes-rated companies managing their safety and health, ergonomic and environmental programs in Michigan and Ohio. She's also completed internships in Finland and North Carolina. Mona is a federally authorized OSHA outreach construction trainer, an Ohio Bureau of Workers' Compensation Learning Center instructor, and she has also received her MSHA Minor Safety Training Certificate. She is a former EMT and EMT instructor, former Ohio firefighter, a Dale Carnegie graduate instructor, and a certified forklift instructor. So how's that, ladies and gentlemen? So without further ado, are you ready to go, Mona?
I am ready to go, and thank you for that nice introduction. I just want to say hello to everybody, and I will be turning off my camera once we get going so you can focus on the slides. I really appreciate everyone signing in today. I don't know that I can pull off Ray's very smooth DJ voice there, but I shall give it a shot. We want to thank you again. I hope you're not suffering from death by webinar. It seems like many of us are in these trying times. And we just hope that we make the next 90 minutes very worthwhile for you. I want to thank you again. And what we have found, at least what I have found, because we had some shelter in place involved too with our positions, and I found that webinars are very good for flexing your muscles in safety. We hope that when you're done today, you will keep at the forefront the truth that safety isn't defined by the absence of injury or a fatality, because sheer luck can always get you absence of injuries and no fatalities. But what we want to impose upon you today is that a solid safety platform it needs to be there, designed in place, and executed in a methodical manner so that you are safe. So what we want to do today is give you enough information to hopefully you will put some procedures in place and maybe save a life. So with today's webinar being an overview, we won't be able to get into anything more than the basics. We do provide a top-notch 2-day course whenever our learning center for the BWC is back online. It is not right now. And what else did I want to tell you? So I wanted to tell you that you may see a small delay. When I hit the slides here, there's probably going to be a 2-second delay on your end. So with that, I'm going to get started. I'm going to shut off my webcam so you can focus solely on the presentation. We'll have the chat available as well. We're going to do some polling questions today and even try to see if we can get a video to work. I haven't done videos before, so we'll see how that goes. All right, join us as we start the course. Thank you. All right, so for today, what we hope to have going, and for some reason, my slide won't change. First glitch of the day. Let me try this. and it's not changing. I'm trying to get to the second. There we go. It's a little slow.
Okay.
That's just a little bit about me. Good. It finally changed. Just who makes me me after hours. I ride horses, have my pets. I'm an animal lover, have a blueberry farm. And then there's me on sledding in front of Lake Superior up by Munising. It's a really cool experience. So like to do lots of fun things. And for our for looking as to why would we partner with ODOSH? We're a different agency. Why would we be out there doing this with ODOT? We're the Ohio Bureau of Workers' Comp. And we just have a shared concern about what's been going on with the trenching and trenching injuries and the high number of cave-ins that we've seen over the last few years. The safety profession as a whole got very concerned about trenching fatalities and cave-ins in the early 2000s because there was a very high pattern of numbers of fatalities and injuries. 2016, they spiked sharply. 2017 showed a sharp increase. Sadly, fatalities are the most likely outcome of a cave-in. For example, there were 130 fatalities with only 45 injuries between 2011 and 2016. 49% of those were between 2015 and 2016. 80% of the 130 fatalities that were logged between that time occurred in private construction. 3 out of the 4 cave-ins resulted in a fatality. The fatality rate related to trenching is 112% higher for trenching and excavation than it is for any other construction activity. That's a huge screaming red flag, 5-alarm fire from a safety management perspective. Also going forward, I did want to mention that I will often say he when I reference trenching fatalities, and the truth is during all those years we've only had 1 female fatality, and she was actually struck by a bucket. That was not related to a cave-in, so I'll probably always say he when I refer to employees, so please forgive me for that in advance. There's some annual background information on excavation and trenching cave-in data. You can see that spike I referenced in 16, 17, 18, 2015. There was and this is from the BLS. So this is from January 1st to December 31st of every one of those years. And just certainly cause for alarm. Obviously, 1 fatality is too many, but to be seeing about 25 a year, that gets our hackles up in the safety profession. OSHA has a little bit different fiscal year, so these numbers don't match up exactly, but you can see they're 20, 25, somewhere around that number every year, which is great cause for concern on our end. There was also a spike in the early 2000s, and that was a really alarming case because one year we had, I don't remember what year it was, there were 45 trenching fatalities. So very big problem. I believe it was 2002. So OSHA launched a study related to trenching fatalities, and that study was released in 2003. Interestingly, all the statistics from that study are still quite relevant today. So we still use them. There haven't been a lot of studies done since specifically on this topic in terms of the demographics that were gathered during this study. But what OSHA found out was that the #1 cause of fatalities were unprotected trenches, totally preventable again. The soil type had not been identified 65% of the time, which is a prerequisite to trench entry. The competent person was not on site 86% of the time. They are there to monitor changing conditions, so it sounds like things may have changed in some of those. Producing was more important than safety 88% of the time. So it was deemed that the people jumping down in the trenches were, we won't say not as important, but I believe there's a lot of denial that goes on. So producing was prioritized in those cases. 65% of the employers involved in the study had, provided no trench safety training. We're finding that to be quite prevalent today. We're trying to rectify that. 42% of the employers had less than 10 employees. So we're talking about small companies, and look 2 bullet points down. 5 or less workers were on the site when the fatality occurred. So again, we're talking about small construction companies, small sites. You know, when we're out in the field, we don't see the very large companies do this. You know, the Danish people, Great Lakes Construction. They're not, the big companies are not really as guilty at sort of cutting corners as the small ones. And the majority incurs in residential construction or, you know, using housing developments. Another finding from the study is that 64% of the fatalities involved a situation where the box was not on the site. So it wasn't even factored into the bid process. It was not there, and no shielding was there, which is a lot more cost feasible. 24% of those cases involved an improperly used box, which we do see sometimes. And then at 12% of the time, the box was there and not used. We see that, actually, I'm surprised that's only 12% because I see it quite often when I'm out. The trench box is sitting off to the side and somebody jumps down to do something. So I see that probably more than 12% of the time, but that's what that study showed. And again, we still use that study even though it was 2003. When OSHA found all of the things that were occurring and sort of some alarming deficiencies in the trench safety practices by employers, they launched a national emphasis program. So it was formulated back in 17, went into place October 2018. It's still going. OSHA will continue to emphasize trench inspections and trench safety. That order will remain in place until it's canceled or replaced by another order. And also OSHA has a really good resource page if you're looking for ways. We're going to get into some ways today in the webinar, but if you're looking for ways to implement some safe trenching practices, they have a really good page on it. And that is linked up there. You can just Google OSHA trenching safety. It's going to give you the same thing. So let's look at what OSHA is doing from a compliance perspective. In 2019, just looking at some of what the citations that were involved then with the trenching citations related to not just fatalities, but cave-ins as well. One in January last year, 212,000. One in November, 210,000. March, 208,000. February, 143,000. You can see it's very easy once violations are stacked to get up to a 5 to 6 figure situation. I do want to point out that these fines were not tallied as a result of the fatality investigation in many cases. I also pulled stuff simply from the National Emphasis Program where compliance officers were in the field and just stopped by a site. So they are heavily enforcing trenching safety, not just as an investigation following a fatality, but doing drop-bys as part of that National Emphasis Program. This year, a couple of the high ones, 303,000 for Cathcart out of Florida and Understall out of Missouri, 224,000. Give you some idea what the numbers can look like. Keep in mind, if there's a fatality involved, it isn't just going to be OSHA citations. There will be more costs. We're going to go over those here in a few minutes. Let's look at who gets involved with a trench fatality. And it's pretty sad when you look at it. It's normally going to be a male between the ages of 24 to 35. We also see a spike in the 45 to 54-year-old range. But normally it's the young people new on the job, again, as we saw from a previous study, untrained in trench safety. So they sort of trust the situation, maybe trust more than they should what the earth is going to do, and trust what they're directed to do without questioning it. They're on the job less than 90 days. They don't have the experience of knowing what the earth can do. They're in an unprotected trench with usually the trench box sitting nearby, as we previously mentioned. They're going to be at depths less than 9 feet. In fact, most of the fatalities are occurring at between 6 and 8 feet statistically. And that might ring a bell with you because you might remember if you do trench safety work that most utility work occurs between 6 and 8 feet. So there's definitely a connection there. So ask yourself, if you lay pipe, is this you? Are you between 24 and 35? Are you new on the job? Do you get in there without an unprotected trench, and are you laying normally? Are you going to be laying pipe? Because 58% of the time, that's what was going on when a fatality or a cave-in occurred. Some pretty ugly outcomes of injuries that can occur as a result of a trench cave-in outside of a fatality. So suffocation is sort of self-explanatory. It's related to grain engulfment, where every time that you exhale, your lungs retreat a little, and then the soil moves in and doesn't let you expand your breathing again, so you suffocate slowly. Rhabdomyosis is an intracellular imbalance where the electrolytes in the myoglobin build up and your blood gets what we call toxic. That's sort of a layman's term. Then the kidneys, then we're to the kidneys. The kidneys can't process the blood. It's so toxic. They also often suffer concussive forces by the dirt and the earth falling in. So we know of people who survive the trench cave-in only to lose their kidneys later and end up being on dialysis for a lifelong situation unless they can get a donor. Amputations, the muscles get starved of the blood because the capillaries being crushed, veins being crushed, and then a lot of times there's amputations down the road because gangrene. Traditionally, you've seen it. If you ever see an old Western movie, somebody always has gangrene set in, so it still occurs today, just because the muscle getting starved of all the blood supply and the oxygen. A lot of back, neck, and leg injuries. There's compression, torquing, twisting, crushing forces involved. Ligaments get torn, tendons and muscles get torn. It's like being hit with a car. So you are going to see a lot of serious injuries, even if you're lucky enough to survive the trench cave-in. Severe head injuries. We had one last year in Ohio where there was actually a head injury that resulted from a stone or a big piece of dirt falling off the side, and that was fatal. Nerve damage is very bad. You'll get the people who have been in a trench suffer neuropathy sometimes for the rest of their lives. We even had a 3-foot trench cave-in last year, and the victim was pulled out very quickly. But in speaking with him, he said he still had not returned to work for several months because of his neuropathy. And PTSD, people can't sleep under the covers at night. Oftentimes, their family suffers alongside them. They can't sleep in total darkness. It's a fear once they've had their life threatened that way. So what else can happen? There's other people, as you well know, if you've been in the field anytime, there's a lot of people out there who have the ability to say how you do your job when you're out in the field, regulatory agencies and those sorts of things. So in 2020, the OSHA fines for this year, which are adjusted annually for inflation, were $13,494 for the lower end fine. And for a willful and a failure to correct, it can go up to $134,937. Criminal penalties, those are going to be on the increase. They're now charging for felonies, including manslaughter. In 2015, there was a change between the fatality cases being tried in the local small courts where the magistrates and judges may not have known about OSHA laws, and the citations and the fines involved were so small that it was not often moved to a higher court. But in 2015, under the Obama administration, there was a change made where the OSHA, the Occupational Safety and Health Administration, is now partnering with the Federal Department of Justice, the DOJ, and they're being tried that way as felonies. So we're seeing a huge increase. I believe between 1988 and 2001, there were about 150 referred over, and I believe 90 were prosecuted, but only 8 of those between 88 and 2001, and that was the only study I could find, only 8 of those resulted in indictments. But already since 2015, since it went to the DOJ and it has more teeth, we've seen, I believe, 6 in the United States where indictment occurs. So usually we're seeing manslaughter charges and jail sentences. Usually it's up to 6 months as a jail sentence, and the fines by the courts can go up into the 6 figures once again. There's some other damages that are pretty self-evident there, legal fees to defend yourself, that sort of things, but public relations are a big issue. So, think about what happened to BP. With the BP Deepwater Horizon event, when there was the explosion, as you'll remember, in 2010, there were 11 deaths, there were 17 injuries. It was the largest environmental disaster in history. and a public relations debacle, BP stock fell by 51% in 40 days. The total value lost to BP was $105 billion. And even though the event happened in April, the CEO of BP was gone by October. So what else can happen? At a multi-employer work site, OSHA can cite anyone on site who's exposed to the hazard. So if you have a general contractor, maybe an electrician and a plumber, maybe some roofers coming out to check out the work site, everyone who's near that trench can be cited, not just the person working on the trench, not just that contractor. The chain reaction is that, and we've seen it rarely, but it does happen, is very much like a confined space where one person goes into a trench, maybe they're only partially buried or fully buried, and the co-workers, being very passionate about their friend, jump in to help, and then there's a second collapse, which is quite likely after the first collapse of a wall, and then you have more than one person. Rescue squads can also fall victim to this, so they have to take a lot of time to set up for a trench rescue. Normally, by the time they get there, 10 minutes have passed, and at 10 minutes, anyone who is completely engulfed with the cave-in will have expired by that time. There will be escalated workers' comp premiums as well.
Hey, Mona.
Yes?
You've been talking now about 20 minutes. I think we should break it up a bit and let's get some interaction going on here. Why don't
That's
you,
funny you said that. Thank you, Ray, because I have on my next slide a note, and I wanted to say what an excavation is, which is a man-made cut, cavity, trench, or depression. So keep that in mind, everyone. But then what's a trench? And I'd like you to put in your chat, how does a trench differ? What are you seeing? What's your opinion? You got your chat button there. If you can just write on out. What's the difference between a trench? How is it above and beyond or different from an excavation? Go ahead, Ray. It sounds like you had something.
Well, I was going to, while they're doing that, maybe you can let me take over the screen and I'll ask a couple of your the Mentimeter questions.
Okay. Hold on, I'm going to give you the screen here. Yes, there you go.
All right, let's see here. Let me do it this way. Does everybody see my screen now?
Yeah.
Okay, so everybody, to participate, you have to get on your phone and go to menti.com, as you see at the top of the slide, menti.com, and then it'll ask you for a code, and you input that 7-digit code that you see there, 7946512. And then the answer, you're going to put A, B, C, or D. Can we see the question? It says, how many of you have seen a trench box properly installed when one is needed? And so it's A is, I've never seen a trench box properly installed. B is, I've seen a few properly installed trench boxes. C is, all of my trench boxes are always properly installed and used. And D, what's a trench box? All right, they're starting to roll in now. This is a good question so that Mona can judge where everybody is on this subject. All right, come on, people. I want everybody to participate. We only got like 15 dots.
We have a shy crowd today.
Yeah, don't be shy, people.
Or their carbs ran out from lunch and they are slumped in their chair.
Come on, we're not even halfway there yet. Let's get a few more people in here.
How many people do we have logged on, Ray?
I thought it was somewhere around 45. Am I right,
Right
Mike?
now,
I haven't looked at it lately.
right now we've got 61.
Oh, okay. All right, only 23 people have answered. All right. You probably can't see the screen, can you, Mona?
I can on my second screen. I'm actually seeing a lot of blue dots, and we need more blue dots.
Okay. All right, 26 people have answered. The majority is B. I've seen a few properly installed trench boxes. 3 people have never seen a trench box properly installed. Or wait, no, yeah, I've never seen it. And then 1 says, what's a trench box? And 3 say, all of my trench boxes are always properly installed in use. So the majority is B. A few, they've seen a few properly installed trench boxes.
Okay.
And,
which is in keeping with statistics. Yep, unfortunately.
Let's ask another one then. Now we've got them on the line here. Let's see here. Let's go to the next one. Okay, this is like a quiz question, everybody. The question is, what does a competent person do at a trenching site? A is pre-entry inspection of trenches. B is determine a soil type. I forget what the other ones are. All right, people are starting to roll in here, answering faster this time around.
Yep, A is pre-entry inspection of trenches. B is determine the soil type. C requests that management allow work to be stopped. And D is both A and B above.
See, we have a comment. Let me see what this is. Okay, we have a comment there to answer your first question, Mona.
Yeah, when we get back to the PowerPoints,
Okay.
I've copied several comments into the chat box for review.
Well, Mona, what is the correct answer for this question?
I'm seeing it. Somebody got it in the chat. It's a specific form of an excavation resulting in a narrow cut. Great answer. Thank you, Ray, by the way, and Mike for helping with that little interactive exercise there. We do appreciate it. We are, again, in webinars and we don't get to see you face to face. So it is nice for you guys to reach out as an audience. Thank you, too. So technically, a trench by OSHA definitions is a narrow excavation in relation to length whose depth is greater than the width, but they're not going to be greater than 15 feet wide. So that was the correct answer. Well done. And you guys are going to have to ring my bell because I'll be honest, I'm not keeping a good eye on the chat. I'm kind of watching my screen. So if there's something pressing, just holler at me and flag me down. I think the most important, go ahead.
Okay. What is the answer to what does a competent person do at a trenching site?
Yeah, it is going to be the letter D. So A, they do pre-entry inspections. B, they determine soil type, which is D, both A and B above. It was a little bit of a gotcha because it says they should request that management allow the work to be stopped. And the truth is, if it's properly executed, a competent person will be the one stopping the work. So we'll cover that in a minute. Great, great, great job, you guys. Thank you.
Okay, I'm going to switch back to you.
Thank you. I'll keep talking in the meantime. So I think the thing that, that we want to impose upon everyone with some of these exercises and some of these questions is to remind you that the earth will always want to relevel. If you've ever been to the beach and you dug a hole and you're having a good time and your family's out there and you want to build a sandcastle, but you got in a spot that was too wet, not going to impress your kids, because every time that you take a scoop, it's going to fall right back in. And the earth wants to do that. That's just a really good example in a very amplified situation that's very visible to you, that yes, the earth does want to relevel itself, and it will. Will it do that with certain forms of stone? Yeah, it still will. It just might take longer. So those are the things we want to caution everyone to, that you should never take it for granted. It will bite you. And for some reason, when you're switching, give us a second, bear with us, because when I'm getting switched back as a speaker, there's a delay in my slide transition. So I have hit the button for the next slide. I'm going to start talking anyway while it waits for itself to change. There it goes.
There you go.
So yeah, so there's a ton of related rules and regulations. Those are on our trench safety page for the state of Ohio. We're going to give you that website here in a bit. I believe it's trenchsafetyohio.gov, but the point being that there are a ton. And on our website, you can go to our website and you can click on them. I've actually got this list copied on the Ohio Bureau of Workers' Comp, trenchsafetyohio.gov website. And you can see that we don't stop short at just OSHA rules and regulations. Ohio Revised Code also has some. And then there's that, we'll talk later about traffic, and then ANSI has some, and we're going to talk a little bit about ANSI today. I think it's pretty important. You know, there are, I want to say, over 7 million OSHA standards, and everyone's always working very hard to meet OSHA standards. With trenching in particular, we're seeing a lot of deficiencies because fatalities are totally preventable, and yet we're still seeing fatalities. So there are things not being done, and there's a lot of standards to meet, but it isn't just OSHA. So we wanted to list them all to let you know there's people outside of OSHA that still have things to say about the way in which you're doing things on your site, digging in and working around your trenches. The common ones we just look to is going to be subpart P, 650, 651, and 652, ANSI, and then the Ohio Administrative Code. The OSHA standard was first regulated in 1969. It was first proposed. There was a Construction Safety Act that was around during that time. And I'm going to say that I was a young college graduate at the age of 12, and that must have been my great-grandmother that was around in 1969. Couldn't have been me. So that particular standard was practiced, discussed, reviewed, and revised in October of '89 as well. It had an amendment in 1994, but basically it's sort of been the same old thing going back decades. So not a lot more is expected of you as contractors. It hasn't changed that much. It's just very important that you look at what is required and follow through with that. We did talk about a competent person earlier. So the rest of today, just to give you a little outline of what we're going to do, there's the competent person discussion. We're going to talk about excavation hazards, protection from cave-ins, additional excavation hazards to look for. And we do want to talk today about safety culture, because we've done studies, OSHA's looked at it. The biggest reason that requirements are not being followed in the field is the overall culture and attitude out on the work site. So we do want to mention that a little bit today and see if we can give you some ideas on how you can do things a little bit better in terms of practices and on-site implementation. So what's a competent person do? Well, this is OSHA's definition. I told you, I gave you a little preview and said we would discuss ANSI, which we will, American National Standards Institute. But OSHA's definition of a competent person is that they have to be capable of identifying hazards and having the authority to eliminate them. That's key. And the competent person itself, it is a very technical job. Anyone on the site is going to look very heavily to that person. They have to be technically proficient. It's going to be someone you can ask questions to. If finding someone who can do the technical part is perhaps not quite so pressing, there's a lot of people on the job that can normally do that. But the question is, you know, that's the easy part, to be honest, picking someone that you can train to do the technical part of the job. It's harder to come up with further criteria, such as who do we authorize as a competent person? If they have good skills, like they're a go-getter, they're reliable, is that going to make your best competent person? It might be the guy who operates the backhoe. those are questions you got to ask yourself. Sometimes your go-getter is maybe not the same person that's going to be the best one for the competent person if they're very good friends with everyone who's going to be entering the trench, and they're not going to correct them. So you have to look at the interpersonal relationships of everybody who's on that team who's going to be entering that trench, and just decide whose personality best fits the job. We do often see in the field that it's going to be the backhoe operator or excavator that's doing the competent person job, but that's not the requirement. OSHA allows you to select the personality and the skill set you best think is going to be able to do that job. They're going to need to know soil classification, use of protective systems, and all the requirements for excavation. ANSI, American National Standards Institute. This is a little above and beyond what OSHA says, because you will remember that OSHA said what? OSHA said that they need to be capable of identifying hazards and having the authority to eliminate them, and then knowing the basic OSHA standards. ANSI says the competent person for excavation should be one who's received training, can demonstrate the knowledge, skills, and abilities required by the standard, capable of identifying all existing and predictable hazards in the surrounding and working conditions that are unsanitary, hazardous, or dangerous to employees. And that has to be a person who has the authorization and the responsibility to take prompt corrective measures to eliminate and control the hazards and conditions. So it is a lot more in-depth. Ray and I give each other points for how many word plays we can make on this. In-depth and digging in deeper business. But the standards are there. They can always be referenced. There's YouTube videos available to train and refresh people. So that's always an option for you. But remember, as far as OSHA is concerned, you might say, what's the relationship between OSHA and ANSI? Well, OSHA can incorporate ANSI standards in two ways. They can reference ANSI standard with their OSHA regulations, referred to as incorporation by reference to another standard, which they're allowed to do. And they can also require adherence to ANSI standards with the general duty clause. So that would, unfortunately, the general duty clause is often seen on a post investigation situation from a fatality, that they don't just usually show up on site and throw out a general duty clause, because they have to be able to reference a standard. But it will often happen as a follow-up, unfortunately, to a fatality. But the general duty clause says that every employer, it's under the OSHA Act of 1970, under Section 5A1, each employer shall furnish a place of employment free from recognized hazards that are likely to cause death or serious physical harm to your employees. So there's a couple of different compliance things there. I'm going to ask you to answer in the chat button if you're looking at what competent people do, and you keep in mind many times before you do anything, you write down, or your planning teams write down what you're going to do. I'm going to ask you to put in the chat box, how many of you have a written plan before you enter that trench box? You know, when you think about it, it's required for a lot of things in industry and construction under the standards. Written standard operating procedures, written job task procedures. Are you guys putting into writing what you're going to do with that trench before you enter it? So if you can wail away there at the chat box and answer that question. Are you having a written safety and health plan for your trench entry before you do it? Yes, no? Got a no? Got one answer. Still waiting, couple more. Do you have a written safety and health plan for your excavations? And ask yourself, do you think it's a good idea? By and large, we're going to get a no, or something that is under development, like someone just answered, and that's true. So maybe it's something to look at, because you will see that, and my slides stop switching here for a second. They'll come up. I just got to wait on them sometime. There's a delay. ANSI actually requires it. Remember that OSHA can incorporate ANSI standards even in the process of a citation. So ANSI does require that a written safety and health plan be developed by the contractor for excavation work that describes the requirements of and the procedures to be implemented. That's for everyone, and that's under just their general requirements. Again, OSHA can reference those. Litigators can reference those. If you were to have a fatality and it were to go into the form of a civil suit, then think about what you're going to be asked in court. How do you defend it? Can you defend it to the attorneys, the judges, to OSHA? Did you have a written safety and health plan for the entry of that trench? Not every trench, that trench. You should have specific procedures for that one because they're all different. Similar maybe in the same housing development, yet still different. We can talk about in a few minutes why that is. So general requirements from ANSI, real quick there. They're things every employer should be doing anyway. Designate an excavation competent person. Instruct each employee in the recognition and avoidance of unsafe conditions and the applicable regulations pertaining to the same thing. Prepare a record that contains the identity of each employee, the date of the training, and the means used to verify the employee understood the training. So that is a verification of knowledge. I've heard it used in court because I study a lot of court cases and sit in on some. OSHA can refer to that as a transference of knowledge. If you trained your employees, can you show that they actually absorbed something, or did you let them all play on their phone the whole training session? So the best way to do that is with a quiz. Show that they understood, absorbed the material that you were trying to transfer to them. Approve all excavation competent persons and coordinate and monitor their implementation of the safety and health plan. So it's a tall order. You know, we understand construction sites move quickly, that you might move a trench along 50 feet in a day. There's a lot going on, but you can have a general entry plan and just modify it for each trench and have toolbox safety talks in the morning, and document everybody that attended. You know, buy donuts, bagels, fruit. You want to be healthy, have them sit around and talk about that trench and sign off that they got trained. It's not as difficult as it sounds. It can be done very quickly and rolled into the job, and it doesn't take a lot of time once you get used to it and just roll with it. So there's a little bit competent person on the job looking there at some sloping. And is it sloped correctly? Well, in order to know the answer to that question, we would have to know a little bit about soil types. So typing your soil is a critical step that must be performed by the competent person. The manufacturers of the protective equipment designed these systems for each soil type. So not every trench box is good for every soil type. And then they also design them for the intended depth of the use and whether or not they'll be stacked. So making a mistake in your soil typing can be a very grave error with serious injuries or fatalities that result from that mistake. Soil classifications. There's a lot in here. It's very technical. Again, it's something your competent person is going to be heavily involved in. But it's easy to remember that there's 3 types. Hint, hint, you know, you might be seeing that question again. There's 3 types, and they're gonna fall into 2 categories. There's gonna be a cohesive soil and a granular soil. And again, this is not a course in soil typing. You can go to courses for that, but we just want you to remember that you want to be a little bit familiar with each type. You want to know what you're working on. You want to know if it's being managed correctly. Things to think about. So there's cohesive and there's granular, and it's sort of the way it sounds. Cohesive contains fine particles that are enough so that they have enough clay so that they'll stick to themselves. Think about them being almost glue-like, but not quite. And think about the more cohesive the soil and the more clay it has in it, the less likely that you're going to have a cave-in. Granular soils are made up of coarse particles such as a sand or gravel. This type of soil will not stick to itself. The less cohesive it is, the greater measures are needed to prevent cave-ins or some type of protection if you're going to enter that trench. So type A soil, it's a compressive strength of 1.5 TSFs. Does anybody know what TSF is? Put that in the chat. You can Google that and put that in the chat if you don't know.
So Mona, we have people saying tons per square foot.
Tons per square foot. Anybody else?
No, we've got about 7 or 8 who said tons per square foot.
Yep, that's good. Yeah, tons per square foot. Wait a minute, I'm not sure I said that correctly. Hold on. Let me pull my note here. Yeah, tons per square foot. I had to double check. It basically it all weighs very similar. That's why I questioned even myself on that one. So, and it never hurts to double check. So yeah, A is going to be 1.5 TSF or greater. It's clay, silty clay, sandy loam. And B is a little more cohesive as far as sticking to itself. It's going to be plus 0.5 TSF to 1.5 TSF. That's going to be angular gravel, similar to crushed rock, silt loam, sandy loam. B is going to be a cohesive soil with an unconfined compressive strength of less than 0.5 TSF. That is the least stable of your soils. That's what you need to think about. Think about C being like granular, coarse particles, anything like that. One thing I wanted to mention about A is that even if you have a C, for example, if you find out it's been previously disturbed, it's going to revert to a type A soil. So not everything is always as it appears. That's why it is a little bit technical to sample the soils. And we also want the competent person to always do at least 2 tests to make sure that they're on the right track with the soils. So there's courses on that. I think at this time I'm going to show a YouTube video to talk a little bit more about soil typing.
Okay, so Ramona, should I switch to me?
I'm gonna, yeah, I might have to. I don't, oh, it came up.
Oh, good.
I think it's coming up. Thank you
Yep.
for offering. We had a little bit trouble with this earlier. If it doesn't come up in a second, I will switch it over to you. I had loaded it and hoping that it would spool through before we got to this point in the webinar, and All right. Thanks everybody for sticking with us. Can you see my screen again? You guys there? Hello? Uh-oh.
I still see the YouTube channel.
Okay. I forgot how to get that off there. My screen, I think. Mike, you got any ideas?
Mike, are you muted? Let me ask a Mentimeter question.
I think I might have, yeah, go
There
ahead.
you
I
go.
think I might have gotten it back, but feel free to ask another one in the meantime, Ray. You're doing such a great job. Thank you.
All right, switch it over to me.
Oh, your slides are back, Mona.
Yeah, got him. Thank you. There was a delay, I think is what I was seeing because I had hit all the buttons correctly. So Ray, you should have the
Okay.
control again.
All right, let's try get this box out of the way. Okay. Can you guys see my screen?
Yes, yeah.
Okay. All right. So the question is, what are the ways to ensure employee safety when an employee is in the trench? So each answer has 3 different parts to it. You got sloping, shoring, shielding, wailing, bracing, ramping, ladders, standby, CPR responders, and shielding, slanting, or sliding. All right, we're starting to have some dots flow in here, but they're all gathering around answer A. I'm going to take a big guess, Mona, and say that A is the answer.
Yeah, everybody's doing a great job here. Yep, slope, shore, and shield. So anyone that knows those 3 S's has probably been on OSHA's site or heard that in training. So you guys are doing a great job, and that's what we want to reinforce. And we hope that when you're out there, in the trenches or digging trenches during the day, just those 3 S's, slope, shore, and shield. We're going to talk about those in detail here in a second.
All right, I just handed
Yeah.
you the
Thank you. Got it.
keys.
Yeah, thank you. Got it back. And I wanted to correct myself. I made a mistake, and this is the disadvantage of live broadcast. I made a mistake because of where it was in my notes. But I mentioned about previously disturbed soil. That cannot be a type A. So people get really confused about type A soil, but I made a mistake. If it's previously disturbed, it defaults to C, not A. A is an interesting soil. I think it's kind of interesting because people want to think of it as like a solid rock or a very hard clay. So I'm going to ask the question, if you guys have been down, traveled to Gatlinburg, gone to the Smokies, done the fun thing, and gotten the luxury log cabin with the nice hot tub. I'm going to ask you to put in the chat, what was it you saw when you were going between, probably on I-65, or excuse me, I-75, going down to Gatlinburg? What do you see? You're going between these bored out, you can see the boring out of the rock walls going there into the Smokies. And what do those signs say? And what are they doing? You'll see that they're doing some work down there also. What do those signs say when you're going into those bored out rock walls? There's signs there's warning signs, big yellow rectangles on the side of the road. And what do they say? When you're entering those corridors with the rock walls, what do those signs say? I know some of you have been down to the Smokies. Put that in the chat, please.
First comment, falling rocks.
Yeah. And that's the comment we're looking for. So if you wanted to classify that as type A, which normally would be the default in the case of most people, they'd say that's rock, that's type A, that's black and white, right? And, well, then why would there be signs that say falling rock? So ask yourself that question. And then now if you go down there, they're putting those chain link fences, they're coating the sides of those corridors of rock that you drive through with those chain link fences. That way, if it does fall, it doesn't bounce. So that tells you right there that even what would appear to be totally type A quote unquote soil is not. And in fact, just a little trivia here, the state of Tennessee has released a mandate that people are not to classify those sheer rock walls as type A. They're outlawing it for that particular classification because there's been so many mistakes made and people can be hurt as a result. So they are taking some proactive measures there as the state. So that's good. That's what we want. All right, moving right along here. Thank you for staying with us, guys. Good answers. Let's see if I can get my change here. And there's another delay. Give it a minute. Every time I get the ball back, quote unquote, when I'm getting the control back as the presenter, it always takes a second for my slides to switch. There we go. So we wanted to talk a little bit about cave-ins today. Well, let me back up before I move forward. So to make the point of correct soil classification, you know, it's easy to make mistakes. There's a lot of training required. I think it takes practice. I would do some on-the-job apprenticing type work to try to get that correct and know you're doing it correct. The 2 tests will help you. There's even labs or lab tests you can do, but you want to have it right on site in front of you. And the one thing, just sort of to mention about correctly classifying the soil, anytime you're not sure, you can always default to C. That means you have to use some form of protection or bracing or shoring. What's interesting is when I've been in the field, I've had a lot of employers, I think they get a little intimidated. We're consultants, we're not compliance, but we do pull up with state plates on. And I think a lot of people get intimidated by that and get worried. And their default is to say, well, it's type A, we don't need a box. So if I walk up, I see nothing but a hard hat sticking out the top of the trench. And almost instantly somebody says, well, that's type A. Well, again, I'm a consultant. I'm not going to cite anybody, but you know, I sort of asked them, well, how do you defend that? What test did you do? Did you do 2 tests? And if they aren't sure still, I say, don't worry about defending it to me. You guys need to ask yourself the question, if something goes wrong and there's a fatality, if you go to courts, can you defend it in front of a litigation attorney? You know, can you defend it to OSHA? If you're confident in how you've typed your soil and you say it's A, which is rare, by the way, in this part of the country as a whole, you know, in Ohio, it's generally going to be B or C. So if you say that it's A, be ready to defend that, and not to me, you know, but to whoever else might come along asking. So cave-ins are the greatest hazards once an employee is entering a trench. Remember, the earth is always trying to fill itself back to level. 1 cubic foot of soil weighs between 90 to 130 pounds, just depending on sort of what type it is, and it will entrap and bury and injure you. So a cubic yard is the weight of a small car. Just 1 cubic yard of soil. They've estimated that depending on where it is in the fall cave-in process and the fracturing off process, it will fall at between a rate of 40 and 60 miles an hour. So knowing that a cubic yard weighs a little over 3,000 pounds and it's falling at 40 miles an hour, that is, think about getting hit by a Ford Focus going 40 to 60 miles an hour. And then think about if both walls caved in on you at the same time. This is why there's more fatalities than there are injuries in trench cave-ins. I'm going to repeat that. There's more fatalities than there are injuries. You're more likely to be killed than you are to be injured in a trench cave-in. What increases the odds of a cave-in? Any additional weight or surcharge on the surface. These can be the backhoe, the cars, trucks, construction trucks driving around, buildings, a concrete mixer, the paver, the stack of stone nearby. Anytime that you're in a trench, if you see the bottom heaving up, that can be that there's excess water coming up from below. That's additional an additional threat to the integrity of the trench. If you see heave, it might be from there's an adjacent building and that pressure needs somewhere to go and you've got a trench box in there. If you see the heave coming up, that means there's additional surcharges many times. The deeper you dig, the more pressure there's going to be on the wall of the excavation. In fact, any trench dug over 25 feet, if you're going to be entering it, requires a registered professional engineer to design the protective systems because there's just so much pressure at the bottom of that trench. Vibration affects it. Vehicles, trains, you can be near traffic, and pile drivers. Those are all going to help to destabilize the soil. Water from overnight rains, underground streams, and leaking pipes. Freezing and thawing in Ohio. What else can we say about that? We see it every spring and every fall, sometimes in the middle of winter. Undermining, that's when people start digging without bracing, maybe under a house to go after a pipe or tie in a pipe, and start undermining. You can also be, somewhere in this presentation, I have a picture of somebody undermining where they're digging under the pavement. So that's another thing that will help to destabilize the trench and create a cave in. The age of the trench, the changes that you see when they age, they're not always visible to the naked eye, but they're going on all the time. And then there's the TYCSs. There's things you can't see. Soil can be previously disturbed. You may not even know it. The problem is once the soil is disturbed and you remove the wall, the remaining soil may have nothing left to cling to. And one thing to think about, I'm from the Kentucky area, and so we had a lot of this going on, but the town didn't have a refuse pile. There was no trash pickup in a lot of small towns. And so people would just make a trash pile, or as I referenced in the Kentucky Southern Indiana area, there's a lot of caverns in the ground, and those were used as the dump for that farm. And you would put it down this little crack in the earth and you'd never have to see it again. And you can go down in some of these caves today. There's washers and dryers and antique cars down there. And I'm not joking. I've seen it. So the TYCSs, the things you can't see, I'm referencing one particular site where they had classified it as a B and they were digging and having trouble, and the wall caved in and they didn't quite understand why, the way it caved in. And it turned out there had been one of those town dumps there or farm dumps there years before, decades before, when they weren't on any of the records, and that particular dump spot had been used and buried over several times, so it was previously disturbed, and it let go. And that's why you just always have to assume the worst with a trench and just do not trust it. So when is protection required? You know, what depth? 5 feet or less, it's black and white. There's going to be some sort of assessment or protection or shielding, you know, often required. The competent person may have to determine the need for it, and they're going to determine the potential for cave in. They're the one that chooses it. And why would you inspect trenches for less than 5 feet of a digging depth? And it talked about that in the video a little bit, but there still may be other hazards. And just remember the TYCSs, things you can't see. So you want to inspect those trenches all the time. The changes every day are not always visible, and you want to make sure you're going to be on top of that before it happens. Cave-ins are going to happen. They're very silent. We staged one, and actually, I'll see if I can get this to go back. That one right there, I'm going to give you a few seconds to catch up. I know you're getting a delay in the field. We did stage this one as a demo at a trenching safety day we had in Signet, Ohio, at the Ohio Operating Engineers. And I was floored when that thing went in. There's just no sound. You don't see them coming. It's not like Hollywood where there's all these bells and whistles going off and everybody jumps out and runs to a safe spot and then the thing caves in. That's not how it works, or we wouldn't have so many fatalities. So you can see a lot of things going on in that particular site, least of not which there's no trench box, but there's tree roots, unstable soil, likely previously disturbed. We don't know that, but you always have to assume that it has been if you're not sure. Surcharges, falling gravel, all kinds of things.
You've got some equipment parked right on the edge of the trench too, don't you?
Yep, that's an extra surcharge there. And it's probably vibrating as well. And it's normally going to be there. That's just why you have to double up on your protective systems. That's a great question, Ray. So yeah, good job. We are going to do a hazard assessment here in a minute. But we'd asked you a question earlier about what were the ways to ensure protection for any worker entering a trench. You guys got it right by and large. Shoring, sloping, and shielding. So those are the three ways. So shoring in particular, it supports the earthen walls with outward pressure. So think of it, I hate to say the word bracing because the bracing is used in other technical terms and OSHA requirements, but it sort of braces outwards, it pushes outwards. That's what a shoring will do. Sloping is when you lay back the soil to remove pressure, and it can be somewhat self-supporting that way. The weakness of sloping is that oftentimes we can't do that when we're out on a site, especially if we're doing utilities, we're running them next to roadways. There's not usually a lot of room to slope. I mean, the ideal is that you're going to do it at least 34 degrees, and that's a big, huge swath of land. There's often not enough room to do that. People will take a stab at it. It's not usually quite the 34 degrees, and so it doesn't count. It's not like horseshoes. It doesn't count if it's not right. Shielding doesn't support earthen walls. It just protects the workers from a possible cave-in. So shields, that's what they're there for. They don't push back. They are there to protect you in case there is a cave-in. You do want to snug up the soil next to them with your backhoe. It takes just a few seconds to do it, and that will help the pressure on that shield in case there is a cave-in. You don't want 2 feet where it takes an additional hit. You want to snug up the soil around it as best you can. Every trench box out there and all the shoring materials will come with a set of instructions from the professionals, engineers who design them. And then subpart P includes appendices that can be referenced as well. So there's a lot of technical data on how to use them, what's correct, what's the best application, et cetera, et cetera. Anytime that you can hit that 34-degree mark, you see the type C there at the bottom. If you can hit the 1.5 to 1 ratio on your sloping, that's going to be correct. Shield system, here's a little hazard find here that's kind of fun. But as far as shield systems, there's a lot of them out there. There's pretty much going to be one for every application. They're often adjustable. They come in a variety of sizes and boxes. Some are stackable, some are not. But let's look at the hazards there for a second. I'm going to ask you guys, I'm going to prompt you to do a chat. Tell us what you see in terms of hazards for that particular photo, which came from OSHA, by the way, with permission. So some things are being done well there, but even with what we've covered today, see if you can pick out what's not being done well and throw it in the chat box.
Okay, we're waiting for comments.
Did we lose you guys?
Can you hear me, Mona?
Yeah, I can hear you.
Okay.
Yeah. Did we lose you in the audience?
Okay, someone typed improper fit.
Yep, good.
Digging in trench box. Trench is too wide. Gap between box and ground on left.
Yep, they're getting good stuff here. Okay, good job, you guys. Thank you for hanging in there. Yeah, it's not backfilled, as you guys inferred. It's not snugged up. Either they needed a wider box or to backfill it. They do some things that are going well. They appear to be using the ladder like they required. And you can't see it, but there's several chunks where it's already caved in a bit. You could see, like on the right there, I could see a little bit better in a large photo.
Mona, one question.
Yeah.
What is the plate on the end?
They put that in there really of their own accord, it looks like. That makes me be a little fearful they're going deeper than we think they're going with that trench box. It's just an extra plate they put there. I don't see that as a requirement. It was something they did on their own. So yeah, it's just an extra plate. A lot of times people will take those and they use the road cover plates, which would be okay if they're certified and engineered for that, but those road covering plates generally are not. Or they'll take a piece of plywood that's a 1/2 inch thick or even 3/4 of an inch thick, but it may not be engineered for that particular use. So what else is the guy doing? I hope I answered that question. And what else is the guy doing there? He's standing a little bit close to the edge. We do have records of a cave-in that was over, it was in one of the Asian countries, I think Japan, where people were standing on the edge because a guy had been involved in a cave-in and they went to see how he was doing, and the spot where they were standing was enough of a surcharge that put that over the edge, and we had 3 of them go down with a stack of soil. So you don't want to really get close to the edge without a really stable soil type. Although he does appear very well outfitted for COVID, I noticed. That's an old picture. I'm not really sure what he was outfitted for, but he's not going to spread anything in terms of a virus. And we're not really sure about whether or not somebody's down in that hole. I don't know how deep this one is. I didn't get a data sheet on this particular photo, so it could be a lot deeper than what we're seeing. So we don't really know. But once you start stacking them, just remember, and they have on this one, once you start stacking them, that generally means that you're going deeper, and then stacking itself puts extra pressure on the box. That's why you want to make sure that you've used the correct box for the job. So good interaction there, you guys. Thank you. I got a hesitation again. Hold on, I'm trying to go to the next slide and it hasn't changed it on my end. It seems like it hesitates sometimes. I'm not sure what's up with that. There it goes. Okay, so talk a little bit about fall protection. We promised you today when we talked about the 4 points we were going to discuss, that we were going to discuss not just sloping, shoring, shielding, competent person, but we said we were going to talk about additional hazards as the webinar moves on. And there's things that would be on any site, even for people who are not trench entry workers, and that's fall. So for fall protection, what's correct and what's not. We tend to see number one a little bit on the left here out on the job. Falls are going to be a hazard. The footing is in itself bad. It's uneven, it's slippery. If you put a hole in the ground, there's a recipe for a serious injury right there on top of all the bad footing, especially up here in the Northwest. We tend to get a lot of ice, and Northwest and Northeast, sorry. We tend to get a lot of ice and slippery drizzle. So it's kind of just, you're sort of looking for a workers' comp claim around these holes, and you want to make them as safe as you possibly can in terms of footing. In the first photo, they're crossing back and forth over that trench with a board. They've taken that time at least to put a board over it instead of jumping over it, which we tend to see. But just remember, since that 1994 amendment came around to the standard, that any trench over 30 inches wide and 6 feet deep has to include a guardrail system for fall protection. And it can look similar to the one on the right. Another hazard, we again promised you we'd talk about hazards. So another hazard you could encounter is adjacent structures. Earlier I referenced we would get to this, and this is where we are. Anytime there's an adjacent structure, the soil can become very unstable if the earth next to them is removed, for example, and just the fact that you don't want to undercut them. You have to support them somehow. It is highly technical. You want an engineer to get involved, and a competent person has to ensure that all the precautions are implemented. Just don't ever forget there's that adjacent structure. You're going to have that as extra weight. You're going to have your backhoe as extra weight, your vehicles, and the materials. All that stuff adds a surcharge to that soil and makes it want to re-level itself faster than it would on its own if you just dug a trench freestanding by itself. All right, here's a hazard recognition exercise. I promised you another one. We're going to ask you to put in the chat what you see that could be wrong with this one. This is a photo I took out on site on a consultation. I was invited in. Tell me what you're seeing here. From what we've learned so far, what things that do you see that you might consider to be an issue? Type your answers in the chat, please.
And Mona, we're seeing no box, person in trench, standing too close, no box, everyone else is too close, undermining of roadway, no box, undermined pavement, people close to the edge, surcharge from backhoe, undercut pavement, obstruction to ladder, no protection, cave in behind him, in swing range of backhoe, no box, and spoil in hole.
Boy, you guys are good. I should turn this over to some of our audience members to give this webinar. You guys are incredible. That's pretty much everything. Yeah, you did a really nice job.
Also, obstruction of ladder.
The ladder needs secured. And I think someone's got their hand on it, or he's leaning on it. So, but yeah, it is if you're trying to get to something. I think, I'm not sure what they meant by that comment, but and by the way, since 2:30 my comments have been cut off. I'm not seeing chat answers anymore, so I appreciate Mike and Ray, I appreciate you filling me in. But
Yeah,
yeah, you
no
pretty
problem.
much got it. Yeah, you pretty much got it. And it's you can't see it from a photo. I have a video of this, and we walked up and got the guy out of the hole and asked the superintendent, what was the soil type here? How'd you type it? And what do you think the answer we got back was? Well, it's a type A. So yeah, I think that's the default answer when people get caught without a box in the trench, but not a type A. And in the video, you can see all this rock while I'm taking the video is rolling out from under this undercut spot, which is a little bit scary. So, and this one wasn't at the 5-foot mark, but this is one of the reasons I took this photo was to emphasize that sometimes maybe you're not at the 5-foot mark, but there's still hazards. He was bent over at one point on his hands and knees, and his shoulders were 2 feet below the pavement. So there can still be hazard at 4 feet, and it doesn't just mean because it's not 5 feet that magically there's not going to be a problem. So I'm going to do one more, I think, Ray, and then I think we'll go to the polling question that's
All right.
on the list. So really nice job, you guys. You deserve a hand. You really do. That was a really nice job on that hazard recognition. I'm getting hesitation. Bear with me. It will come. Okay, there we go. So underground utilities, everybody knows that before you dig, you call Ohio 811. I think everybody does a pretty good job with that from what I've been working with the Ohio 811 people for a little bit. And there is a requirement. We have it linked. They have it linked as well on their page, but OSHA requires under 1926-651 section B3 that when an excavation operations approach an estimated location of underground installations, the exact location of the installation shall be determined by safe and acceptable means. And then there's also an Ohio code referencing that. So it's mandatory across the board, and they will always come out usually within 2 or 3 days, if not sooner. And then you've got those markings on the ground, and it's amazing. I'm sure many of you have ever had this. If you've ever had it done, it's kind of interesting to do and to realize that there's a lot more down there than you think, and there could be dead lines you don't know about. I've had it done here, and there were dead electrical lines I didn't even know were under the ground. We weren't using them. They have a really cool app. Probably many of you have the app loaded. But Ohio 811, you can go to their site or you can go to the App Store and pull the Ohio 811 app. It might be under Ohio Utility Protection Services, OOPS, but I believe it's on their page. So you can link up to that, get their app. It's actually a bit of fun because there's a section on it when you can go there, especially if you're on a big construction site. You can go there and see what tickets have been pulled in reference to Ohio 811. We joke about that too. We call it the Nosy Neighbor app. So if you're gone from work all day or if you come back from vacation, there's flags all over your neighbor's yard. You can find out what they're doing before they're doing it. No way to hide that. Not in this day and age. All right. I am going to ask then if you can go ahead and launch another polling question.
All right. Send me
Yeah.
Yep.
Give
me the keys so I can drive.
All right, all yours as soon as you get them. You stay in your lane there though, Ray. I'm very bad with my peripheral vision. Stay in your lane.
All right. Let me see. I have to hit escape. Here we go. What is a spoil pile? Is it the answers are there on the right? Something I have at home to compost my garbage? A pile of dirty laundry next to, I don't know. Now I can't read them.
Oh, it went away. You know what? We had that trouble with another program we used. So A is something I have at home to compost my garbage. B is a pile of dirty laundry next to the hamper in my kids' room. That's a spoil pile. C, it's the piles of leftover scrap lumber that are left over from a project you did on your house. And D, it's a pile of dirt which has been dug up.
Well, it looks like we're getting a lot of D's. So I think they got it.
I think they got it. They're paying attention. They're doing good. You guys, I really appreciate you being interactive. It helps us. Statistically, it helps you when you're interactive. So we really appreciate that you're taking the time to do that. So yeah, it's a pile of dirt which has been dug up. It's not your compost pile for all you people that are, doing that sort of thing. I have horses, so I have a different kind of pile out back, and those are
Here,
interesting.
let's
So
do
yeah,
another one. They're
you want
so
to do another one?
smart. Let's see if we can get them on this one. How many classes of soils are there? Let's go by the numbers. So it's either 4, 3, 2, or 1. Well, we're getting 100% of answers are on 3, which are A, B, and C. What do you think, Mona?
God, they're doing great. Yeah, you guys are rocking it.
This might be
Awesome.
this might be the smartest class in LTAP history.
They're really doing well. I think they paid attention
All right.
during the OSHA video, and no, they did very well. So appreciate you guys getting involved, and kind of maybe not always the next thing, you know, to put you on the edge of your seat like some Arnold Schwarzenegger movie, but it's something we have to do, necessary
Okay.
for the job.
You have the
And
I gave you the keys back, Mona.
thank you, got it back. And so we appreciate what you're doing and staying with us. We are coming down to the wire here. We got about, I don't know, I'm thinking another 20 minutes left. Let's see what we can do. So you're right about the spoil pile. You guys got 100% correct. Yay, you. And that's what spoil piles are. They're just what you've dug up and out. They must be set back 2 feet. It helps to ease the pressure along the edge. Now, what I want to emphasize, and I've seen done in the field, I'm sure none of you would do it. You're very astute with your technical compliance, but I've seen contractors pull up the soil and stick it on the edge, and when they see my car pull up and it's blue and it almost looks like a state trooper car and it's got the state plates, what I've seen them do is when they see me pull up, they look at that 2-foot pile right up to the edge, or that pile right up the edge, and they run over with their tracks. And now it's all smushed down. So they think, well, that track was about 2 feet wide, so there's my 2-foot minimum gap. But when we talk about surcharges, think about what you just did. You just took a spoil pile, which was already heavy, and you smashed it down towards the edge of the trench with your tracks. So that just put an additional bunch of pressure on. And I've watched them do it, and you can see clods of dirt start rolling down in the trench because it wants to give way. So rolling over the spoil pile doesn't serve as a 2-foot setback. If spoil piles are not set back 2 foot, this is sort of interesting too. So if you've got dirt right up to the edge and you haven't set it back, and if OSHA shows up, they'll measure the depth of your trench from the top of the spoil pile to the bottom of the trench. So if you have a 4-foot trench, but you have a foot of spoil pile that's not set back, they will measure from the top of the spoil pile to determine the depth of the trench, which is really almost correct from the perspective of pressure on the soil. All right, so we talked a little bit about traffic hazards before. We just wanted to mention, of course, that there are requirements for traffic hazards, how to work around traffic, whether or not to use a flag person. When we're out and about, I almost need to turn it over to Ray at this time. I'll just say when I'm out and about that I don't see compliance very often to the T. It is a very complicated set of codes and requirements. Ray, what do you want to say about the MUTCD?
Yeah, we have the Ohio Manual of Uniform Traffic Control Devices, and they can get a direct link to that manual right on our Ohio LTAP webpage under Resources and Programs. There's also an app they can download to their phone to help them set up their work zones properly. And Mona, if you ever see a bad work zone, feel free to take pictures for me.
Okay. Oh, lots of times. It's almost like trenching. I hate to say this, but if you got technical, it's easier to find people out of compliance than it is in compliance. Again, we're consultants at the Bureau, but I would like to see people doing more out there. And again, I think we're back to the larger companies. Unfortunately, when we see the larger companies, they seem to do a better job than the smaller companies at compliance. So it is what it is. We just got to keep working with it. And that's why we're doing things like today, doing webinars to help you get clarity on what's really required. But the app is great, by the way. It's an awesome app. It's easy to find too, because it's, yeah, you're welcome. It's easy to find too, because it's a bright orange icon, and everything else on my phone seems like it's blue.
Well, I'm updating my work zone class. I'll be rolling that out at the beginning of the year. So we'll send out some flyers to advertise for it.
Yeah, excellent. It's a really good class, and Ray, you do a really nice job when you instruct and train, and I think you do what OSHA calls transference of knowledge very well.
Oh, thank you.
You're
You got to
welcome.
start wrapping this up. I think we're supposed to end at 3.
Oh, I thought it was 3:30. Okay, I
Oh,
will
is it?
wrap it up.
Which one is
Whoa,
it,
whoa.
Mike?
Hey, folks, I believe this runs till 3:30.
Okay, thank you, Mike. My bad.
Thanks, Mike.
Yep.
No, that's okay. I think Ray, you and I had talked about 3 o'clock. We talked about 90 minutes to allow for questions, and they're doing great.
Okay. Yeah,
I
we're
think that's
doing
where
great.
we foiled ourselves. But no, it doesn't hurt for you to check, because you know what? I could keep talking. So I'm passionate about this topic, and I know
I know
you
you.
are too. Or you wouldn't have asked us in. So thank you. So mobile equipment, and in addition to the surcharge that mobile equipment adds around the edge of a trench, bad things can happen. Do I need to say any more besides that slide?
No, but
Uh,
I'm glad you showed it because um, there's a lot of trenching goes on, across roadways. So that's when you mentioned trenching with ODOT. We're concerned about the trenching across uh, roadways to install, culverts and water lines and all that stuff. So
well, and that's a really good point that I need to I'm putting a note in my presentation for that. And I don't know how many of you have ever been out west, but if you've ever been out in South Dakota, they got those buttes that have a flat top. And in the old days, the way that they used to, way old days, for guns and all that, the way that they used to sometimes get their meat was they would drive a herd of buffalo off the edge of a butte, because you can't see, your eyes cannot distinguish between the edge of a butte and the grassland in front of it. So they would drive the buffalo off the edge of these buttes, and the ones that fell, well, that was dinner. So it was, they were survivors. But it is, if you see a flat area or even a slight incline away from you, and you are walking along or driving along, you may not see, if it's not marked, you may not even see that there's a trench there, and then you're going to bottom out like this particular individual did. So not good. Just one more reason to be safe around them. Mark them. Train people. Don't let anybody on the site treat it like a very high incident situation, because it has the potential to be a very high incident situation. So what additional hazards besides traffic and surcharges and buildings and water is another one. We're going to talk about hazardous atmospheres, and anytime there is water, you're required to provide some way to empty the trench of the water. But guess what? Now you may have just introduced an additional hazard. So there you have an internal combustion engine trying to pump the water out and keep it out. These guys don't, at least one of them doesn't look like that guy in the blue doesn't look like he's within the confines of the shield. If any of them are, I don't think any of them are. I think the photographer was in the trench box here. So hazardous atmospheres are there. Think about that landfill of that example as an example that we used, where there was an old landfill and no one knew about it. So it was also leaching off gases from the old things that had been dumped in there. When they put a crack in the side of that thing, they did find that the gas levels went up. I believe the methane went up. So looking at this, probably you may have heard the word hazardous atmosphere before, and you probably heard it in relationship to a confined space. So is a trench a confined space? I get that anytime I teach a class, and you may have that same question. So I'm just going to throw it out there. You guys put in chat, if you will, is a hazardous atmosphere, is a trench a confined space? Yes or no? Do you think a trench is a confined space? Would it qualify as a confined space? Does OSHA look at it as a confined space? Yes or no?
We have the first comment says yes. Second says depends on dimensions. Third says yes. Fourth says yes. 5 says by OSHA definition, yes. Next is yes, potential for entrapment, hazardous atmosphere. Then yes, and yes again.
Yeah.
And several more yeses. Yes, if atmosphere may be contaminated. Yes, but not a permit required.
Oh, that's a good answer. Good answer. Okay. I got one yes, and that's all I can see on my chat. I don't know why. I've got the rock slides answers on my chat, and one yes, and it cut me off. So thank you for filling in the blank, you guys. So is it a confined space? Well, again, look at the definition. Any area not intended for human occupancy, limited means for egress and exit, capable of being entered. If you look at that definition, absolutely it's a yes. And I love the comment about the permit, because technically we don't have to require a permit. But when you reference that ANSI requirement that we talked about earlier, that we would like to see people implementing a written safety and health plan for entry, it starts sounding a lot like confined space. The competent person always needs to look at similar hazards like you would have in a confined space. As somebody mentioned, the potential for hazardous atmosphere. And there's a lot of things like oxygen levels need to be checked, carbon monoxide that can be produced, even though it doesn't really appear to be lower. Carbon monoxide is not really heavier than air, but the wind can push it down into the trench. So there's this very similar, it's not technically confined space from the way of OSHA. It's nowhere in the standard that it says that, but it is a mirror of what the confined space standard is. When we teach when we were able to all gather in public and we had the trenching seminars, we always had the confined space piece included and compared and contrasted. So it is important to know. It's man-made and it's temporary, but yes, you can have engulfment, entrapment, that sort of thing. So really good discussion, you guys. Thank you. Very good answers. Very
Hey,
good. So you
Mona,
know your standards. Yeah, go ahead.
a few other questions and comments. One question, do manufacturers put an out of service date on trench boxes?
That's a great question. A manufacturer would know that, and United Rentals would know that. I know that they have to be inspected, and I think they just go by the inspection, because I will look that up if you can get the email of the person who asked that, and I'm going to write that
Okay.
down for myself. I don't know of an expiration, because your inspection is going to find anything. If you properly inspect your equipment, if there's rust or cracks, you're going to find them with your inspection. I don't think they put expirations on it. They may have a requirement, sort of like cranes, to be resubmitted to the manufacturer or re-inspected. But I'll find out. That's a great question. I've never actually been asked that.
Okay.
I
Next
will look that
comment
up.
was, looks like the box doesn't go all the way down to the bottom.
Yeah, it's really hard to tell. It does. Well, it almost looks like they're stacked. Looking at that picture, it's hard to tell. I would not argue. It looks like it's either floating, or my thought was they're outside of it. They're not where they're supposed to be. And I think the photographer's inside of it, but it could be. It's hard to tell from that photo. I don't have again, it's one I don't have a fact sheet on, or a hot tip sheet on, so I can't tell, but it's very possible. There's a lot going wrong there.
What one person just typed in, it looks like shoring.
I'm not seeing panels. Yeah, I'm not sure what we got going on there. It could be shoring. That's a really good comment, because almost in the top left-hand corner, that almost looks like a piece of wood. I really can't tell. So great
And
comments though.
there's a follow-up question. I think this is regarding trench boxes. How often do they need to be inspected and by whom?
I will send out a technical sheet on that. There are answers. It should be before every use, but I believe OSHA has a fact sheet. And if they don't, I know where I can get one.
Okay.
I have vase. So inspection for the boxes.
All right.
But
Thank
yeah,
you.
just like, yeah, you're welcome. And I appreciate you guys filling me in, because I'm blind to that chat for some reason. I'm unusual. I still have an answer at 3:07. I got one yes, and that was it. So I will get some information on that, and that will be a handout. Ray, do you have the ability to email everyone afterwards and send out one more handout?
We can,
Yeah.
our LTAP office generally sends out follow-up emails with links to the webinar recording and resources. So yes, we can send out
Okay.
information.
Thank you. We'll do that. So I'll get you a fact sheet on that one way or another. But certainly, my answer, the obvious answer, is before every use, for every time you put them in. I don't know if that happens. I've seen some pretty banged up. Those trench boxes really take a lot of beating out there. That's for sure. So great questions, guys. Keep them coming. All right. So hazardous atmospheres, monitor for those, treat it like a confined space, take additional precautions. The competent person will be the one who is really going to be working on that and developing preventative and precautionary measures, as well as doing any sort of monitoring. So another hazard, promised you we'd get to water accumulation. One point of interest is I live in Northwest Ohio. I'm in what's called the Great Black Swamp area that covers, I believe it's 16,000 square miles or something of Northwest Ohio and dips down into Indiana. And we have a water table here that at times is a little bit around 4 feet. If we have had some heavy rains, it will get to a 4-foot point. And I have to have in my well house, I have a well, and I have to keep a pump going for days, and it's because it comes right back in when you get it out. It comes right back in, and worse than just soil seepage, we have a very high water table. One year we first moved here, we were laying an additional water line, and we rented one of those handheld, push behind trenchers, and things were going well. And but we dipped into a swale, and then we learned, coming from the Kentucky, Indiana area, I got to learn about Northwest Ohio soil, and it was caving in. It was like whipped cream almost, or pudding. And as soon as the trencher dug it, it was caving in. And we were trying to lay the pipe, and the pipe was getting knocked around so much by the soil caving in that it was very tense that year, because we got it as deep as we could. It kept caving in. We kept getting the pipe as close as we could to the trencher without shredding it. And then going into winter, we had some tense moments because we weren't sure we got it at 4 feet, and we were ready for our pipes to freeze, but they didn't. I believe God was with us, or somebody was with us, and somehow we got it down, and they have not frozen, but it looked like it was going to be that way. Now, if you get to the point where you see water accumulation in a hole, you have to start thinking about getting a registered professional engineer to look at it, to see about water removal, what equipment is needed, what precautions need to be taken for that. Again, the competent person is going to have a say-so over all of it. So if you're wondering what OSHA citations would be involved that we see the most, and keep in mind in Ohio, OSHA does not cover, and I know that if I'm speaking with streets and people for village, you know this. So any municipality is not covered by OSHA. In Ohio, you are covered by the Public Employers Risk Reduction Program. There are PERP people who will be in charge of support and assistance for any city, county, township. You will be working with PERP instead of OSHA in Ohio. We're actually lucky to have that requirement, because in a lot of states, public employees are not covered pretty much by any particular oversight group. So there aren't a lot of recourse if something goes wrong. Well, they didn't have any standards to follow, so what could we have done wrong? But what OSHA does, what in terms of citations that we see, and OSHA will tell you that the number one thing that they see, that they cite for when they're out in the field, is that the trench is 5 foot deep and there are no protective systems in place. There I've listed the standard that requires that, still under subpart P. There's going to be a ladder not located every 25 feet in a trench over 4 feet deep. So somebody commented about that ladder in that undercut pavement photo we had. So it is required. It just has to be, you want it near the proximity to where they're working. You don't want any obstructions, so that if they went to run for the ladder, they couldn't get out. For example, there was a big pipe in that picture. So that's not the ideal placement of the ladder, but minimally it's required at least every 25 feet. If you want to go above and beyond that, remember, you can always go above and beyond what OSHA says. OSHA found that there's no pre-job or daily inspections completed by the competent person. The protection for employees from spoils and stockpiles that were not often set back 2 feet. There was a fatality in Dayton about 3 weeks ago where something rolled into the trench, and I haven't seen the requirements on that. It's still being investigated, but if you should be setting everything back 2 feet to make sure that that's not something that would be likely to happen. Competent person, not removing employees from the trench, not using their authority, and it's such a big deal to have that authority, but then to use it. If it's your friend and they're trying to get something done, you still need to crack it and say, hey, get out of there. I need to get you out of there. I'm the competent person and we see a problem. Trenches over 5 feet have not been approved by the competent person. Employees are stepping outside of the trench box. Trenches near a roadway without a traffic control system. Ray, I mentioned I see a lot of that. There might be no air monitoring being done if there's, because OSHA says if a hazardous atmosphere is or can reasonably expected to be present, then you have to be doing the monitoring full time. So everyone on every site really should have a 3 or 4 range gas monitor available to them, whether it's on the truck. You should always have that there. Trench is not re-inspected with changing conditions overnight, rainstorms, drizzle, 3 dry days in a row. You know, you should be doing it every day, but at least, and certainly if there's some dry conditions, it's going to maybe crack and change the way it behaves. Other common hazards. This is one of my photos, so you can see, remember I said that the ground could crack if it got dry. If you see as to where that arrow is pointing, you can see there's pressure crack in the ground. I mean, it helped that somebody was rolling near with a surcharged load of a vehicle, but certainly it's not up to snuff the way it is. A lot of times we'll see a trench box with just one cross spreader, or it's damaged. We inferred that trench boxes take a beating earlier. Trench box is often floating. It has to be within 24 inches of the bottom of the trench, and a lot of times it'll be 3 or 4 feet. Someone mentioned that in that previous slide, and that was a very keen insight, because it does have to be within 24 inches of the bottom of the trench. Water can accumulate unchecked. Fissures or other signs of instability are not monitored by who? You guys know the answer here. It's a competent person. And one more slide on this. Other hazards we see are people working in the trench with live utilities or non-supported utilities. That's a very technical entry, but I have no doubt you guys run into that. If you're anywhere around utilities and they have to stay put and you got to move around them, it's hairy to do, but it's doable. And then they do have to be supported. Leaping over a trench that's 6 feet in depth and not 30 inches wide, sorry. Employees out of the line of the side of the excavator operator. Again, that's hard to do for functional capabilities on the job. It's almost always you're going to end up at some point where you can't see the operator of the excavator or the backhoe, but it's something that you got to strive to do. Employees not wearing PPE, fall protection if it's needed, and that sort of thing. And the box does not extend 18 inches above the top vertical side of the trench. That's not always a requirement, but if it's likely that you're going to have some, like on a hill, you do have to have it 18 inches above. I'm not gonna go to chat on this one because we are getting close to the end we're getting close to 3:30 and I don't want to keep anyone over. We're gonna talk a little bit about rescue personnel. One comment I just want to make here is that we learned that for the state of Ohio, that there's actually less than 8 crews for the state of Ohio, and this is something you want to think about, who are fully equipped for trench rescue and whose people are all certified for trench rescue. So there's less than 8 crews in Ohio who are fully ready to come in the event that there is a trench cave-in. Knowing that you have anywhere about 6 minutes before you expire, knowing that it probably is going to take 10 minutes to get to you, or it's going to take them a long time to get on site. There's 88 counties in Ohio, and we have 8 crews that can respond to a trench cave-in. So it just tells you really don't want to have one, because it's probably going to end up in a fatality for all the other reasons too, but just for lack of availability, have a nearby response unit. Best way to avoid hazards, doing a job bidding them in. I've talked with contractors that said basically if you're going to do the job right, most jobs, especially big ones, if you're going to have the trench box there and take the time to do it, it's going to be about an extra $3,500 if you have to rent it, take time. They included their time in that, and you need to bid that in up front. There may be little shaver guys that come around that outbid you on a job because they don't include the trench box, but they're playing Russian roulette with that trench. So things to consider is the traffic patterns, proximity to adjacent structures, soil classification, surface and groundwater sources, utilities over, under, around the job, average weather during that job for that particular region, quantity and type of protective systems that you're going to need, fall protection needs, number of ladders that you may need, and any other needs that you identify. Remember that ANSI requires you to have a written safety and health plan prior to entry, not after, when things aren't going well and you're trying to scramble. There's alternatives, hydraulic and pneumatic shoring, which is very fast. And they're looking, and if you guys have been in any of these big cities, or especially out in California, they have a lot of this going on, these directional boring machines that are man-eaters. Or you could look at, A&E channel has a show, I can't remember what it's called, Masters of Engineering or something like that. Pretty fascinating work going on. Pipe ramming, pipe jacking, relining the pipe, the cured in place process, where you can use an old pipe that's dated. Our infrastructure in the country right now is experiencing a lot of dated infrastructure, and you can actually cure a pipe in place. So those are alternatives. What is your safety culture? You know, we see a lot out there. I've made some inferences to it, but I don't really have time to put a chat on this. We've done a lot, and I don't want to take your time too much, but I want to end on time. But, you know, do you have a catch me if you can? I'm going to do this. Nobody's around. I'm going to jump down in there and, you know, tie in that pipe. Nobody will see it. Or do you, maybe you're doing enough to get by. I'm going to have a trench box there. I'll probably have it in the hole most of the time. I train my people. I do safety training. I have this stuff there. That's not bad. That's a step above. And then there's world class. And by world class, we mean the people that I inferenced 2 slides ago, I believe, that said you're going to plan it up front, you're going to quote it in, and you're going to send it to in on the bid jobs that way. So if you think that you have a world class organization, and I ask your employees, how do you think your employer rates? How would they rate you? Would they give the same answer? Would they rate you world class? What a healthy safety culture is not. It's not a culture wherein management values production over safety. Management shows little to no leadership, where supervisors are not held accountable. Supervisors fail to enforce safety rules. Those are the competent people that are in charge of your safety. And if they bend the rules, that's a downhill effect that's going to trickle down to you. Supervisors violate safety rules. Management measures safety solely on the number of injuries or injury costs, because we talked about increased workers' comp costs. There's so many indirect costs. In the safety profession, we do a 4-to-1 ratio, which means for every dollar that you see for injuries, there's going to be $4 you're not seeing for time spent on the investigation, the job shutdown, retraining employees, rehiring employees. There's a lot that goes into that. A world-class culture means that there's actively involved in visible management, that there's safety designed in during the planning stages of the bid process, like we talked about, having engineers involved right up front to help with your planning and estimating the cost. Having metrics and measurements and job performance descriptions that are based on incident prevention strategies. So not just, we went this many days without a lost time, because that's like watching the touchdowns on the football field and saying, oh my gosh, the other team is beating us, we're down 14. Maybe we need to look at a different play. So we want you to be looking at prevention up front, and not measuring yourself by what has already happened, because that's downstream. That's done. You can't go back and fix it. World-class culture means that employees are valued and included. They are authorized individually to get involved with any shutdown procedures anytime they feel unsafe, and they will suffer no repercussions. They are involved in pre-job and site-specific training, even if it's a 5-minute toolbox talk in the morning, and they're rewarded for expressing their concerns. We like to give people even gift cards, $5 gift cards or $10 gift cards for, you know, bringing concerns forward. So we covered a lot today, a lot of information. Some of it was technical. Don't feel like we're going to send you away from here with absolutely no resources and no help. We have a whole list of them: OSHA, the Ohio BWC, PERP 811, the manuals we mentioned today, NFPA, which has the technical rescue for trenching, NIOSH, and the local EMA. I'm just going to flip through a couple websites here to let you see what they look like. There's ours, trenchsafetyohio.com. And last but not least, we do on-site consultation, all kinds of good stuff. There's PERP. So you guys are going to rely heavily on PERP if you are in the public sector. That concludes my presentation. I want to thank everybody for their input and their chats and their answers and considering this and just taking time to sit through it. So thank you very much. Ray, I'm
Thanks,
going to
Mona.
turn it
Do we
over to
have a
you.
comment? Great webinar, gets people thinking about safety. So excellent information. Thanks so much for presenting, and thank you, Ray, and everybody else for being part of this webinar.
Yeah, thank you everybody for attending. And Mona, you did a fantastic job. And Mike, you're going to be, or what? I'm going to be uploading this to our Ohio LTAP page under our archive webinars, right, Mike?
Yeah,
And I'll
and
have
we'll
the,
send out a follow-up email to the participants with a link to the YouTube recording and the handout materials.
okay. And if you have any questions, get a hold of us at Ohio LTAP. And thanks again, everybody. We'll see you at our next webinar.
All right, thanks.
All right.
Thank you, guys.
All right. Bye-bye, Mona.